right, great. Let me make sure I've got that going. All right, so if you came hoping to be taught free, that's not really the focus here. It's more like our experience story. Kelly had a great talk on Friday. If you missed it, I really advise the video. So, little quick background. I've been about 7 years working for Comcast, about 7 years playing with Scala. I'm a technical lead on our team, so I have the distinct pleasure of being able to bring in new techniques and champion new approaches within the team. And that includes Scala, which I've been championing for probably about that same 7 years, and working full-time in about 2 at Comcast. So we develop platforms. And we had to develop a portal for our platform so that it could be self-service, because platforms stink if you need a lot of help and tickets and things to get started and get going within Comcast, which a lot of things do. So we were in a spot where we were developing code. We had code that was hard to understand, very unpleasant to change, and the team was very frustrated and unhappy. And it was like Lord of the Flies kind of situation in our team. So we said, hey, what about the free monad? And actually the team brought this to me, and it was a technique I was already interested in. So I said, yeah, let's go. Let's pursue the free monad as an approach to do this. We can, capture the structure of our computation. We can interpret it later. We can have the different interpretations for testing and production, possibly analysis. It'd be really useful, including, we could use cats. We'll build our simple data types, and we'll describe our algebras. We'll combine them with coproduct. We'll build simple interpreters, and we'll combine those interpreters. It's easy, right? Like, no problem. Let's just go. So we watched a lot of talks. I watched NARS Talk. Rahul Raja has the functional programming patterns version 3. I highly recommend as an approach to this. The big problems that I would say that exist are that a lot of the talks are sort of toy examples. You can't do real examples in a talk, honestly. But it's sort of hard to, you have to take those examples and sort of translate them into the reality of getting your job done. So what did we do to get through this? At first, we sort of had everybody run off and try to learn free on their own. That didn't work, and we had, maybe 2 or 3 different approaches to writing the code and developing everything. And so I said, okay, we got to stop. This isn't going to work like this. We got together in a room and we started from scratch. And I took the very first endpoint that we wanted to implement, and I said, what do we want to see here? In our case, it was like getting all accounts. And so we said, okay, let's write an algebra that's all it does. And then we slowly added to that. And for that first thing, we built a very simple interpreter that was purely in memory, didn't do anything real. And I continued that approach as we built up algebras. And everything was synchronous, it was in memory, they were all mock, great things we could use for testing, but they still didn't do anything. So I was still getting kind of sideways glances from the team, like, hey, you realize you're not doing anything yet. But once we were ready, once we had enough momentum built up around the algebras, I said, oh, you want to do something real. Let's take one of these and make a real interpreter. Go hit the data source. Go pull out the data and return it through. And that's, I think, when the lights really turned on for everybody, because they suddenly went, oh, you just went from having nothing real, to having something real in a few lines of code. One approach, we use play within our team. One approach that we did, we created a custom play action, which applies the interpreter. One of the first things we noticed was if every action is going to be running free, they're all going to be running that same code that maps the interpreter over the free. Probably want to hide that away, make it look cleaner. So our play actions literally look like they just take free for comprehensions and build up free structures. And all of the common interpreting all happens in one place, which is really nice. So all the code became much cleaner and easier to look at. So how did we design an algebra? Would probably be an actually better question. So you want to consider exactly the code that you want to see, right? What are the inputs? What are the outputs? what are the complexities that should or could be hidden? That's an actually important question. A lot of my team wanted to be like, well, this is something we should be concerned about. It should be in the algebra. And I had to kind of say, well, that's something that, yes, it's a concern, but it's one we can push off to the interpreters and not worry about at all in our controller. And concurrent modifications was the big sticking point there. They said, oh, we have to expose the fact that we're doing an update so that we can do CAS values and all kinds of stuff. And I said, well, first of all, there's like 3 people hitting this at a time, probably not as important. Let's definitely push it off. I'd much rather see you say, get something, make a modification, put it. That's what I want to see in the controller versus an explicit, say, update step. So we also hid away things like access to the play request. And also, we can hide things like retries. If we want to do retries on an interpreter, we can kind of hide that away from our business logic, which was useful. So designing an interpreter, right? All of your interpreters with free have to produce the same output monad. This doesn't mean that you have to build all of your interpreters to produce the same output monad, as it turns out. We made very good use of the functional abstractions available in CATS. We applied monad error where possible. If an interpreter didn't care what monad it was in and all it cared about was signaling errors, we went to monad error. We hid the play request in Cleaver, and we very explicitly said, hey, most of the interpreters don't care about the play request. So let's lift them up to Cleaver rather than having them worry about the full details. This made our interpreter design a lot simpler, and it made combining them later easier. Also consider, consider Cleaver for things that you want to hide away and pass through to every interpreter, and state T for things where you want to store state. So our CAS problem, I approached my developers and I said, hey, we can solve this with state T, and we can solve it in the interpreter. And most of our interpreters won't care, and only the one that deals with CAS values is actually going to care about that. So the lifting transformations that I mentioned, they became very important, right? We lifted to Cleaver, you could lift from Cleaver to state. We could build lots of those different kinds of lifting interpreters, and that made each individual interpreter much simpler for the developers to grasp, and then later combine them into more complicated structures. And then also our individual interpreters are protected from changes to our output. So if we want to change our output monad, most of the interpreters aren't actually going to care. We started building, we have an interpreter to XOR. We have an interpreter to future. We ended up with, hey, there's one interpreter to monad error, and it covers both of those cases very cleanly for us. So what do you need? We used CATS. I highly recommend it. It provides all of the base free support, all of the useful functional abstractions that we used. The kind projector is critically important for a lot of this stuff, I find. Being able to write your types in a clean way and not have to do type lambdas. I understand type lambdas. Most of my team does not understand type lambdas. So it was even when we were using them, I had to kind of hide them away a little bit so that they wouldn't worry about them. And then also, Miles's SI 2712 I put in so that we would write a lot less types than we were writing previously. Now just upgrade your Scala version, and you should be good. More tools would be good. I was pointed towards Freestyle last night, and I looked at it today, and I'm very excited to try to bring that to my team. If you're just starting out, there's another library called FreeK, which is interesting. We were very far down the CATS coproduct path, and using FreeK would have involved a lot of changes to the code, and so we didn't go that approach. But I did build some other tools that we used to sort of fit things together in a clean way and reduce boilerplate. So a simple example of of an interpreter which, what does that look like? Yeah, there we go. Simple example of an interpreter. This is, I mentioned retrying errors. So this is an interpreter we could build wrap it around another interpreter, and also provided a function that says, hey, given an error, how many times would you like to retry that? And it's built right on monad error so that we can be fairly flexible here. So we take in the input algebra, and we need to produce our output monad. And so, I wrote the simple attempt. Attempt is going to say, translate the interpreter here, use the interpreter to translate, and then handle the error by checking, and if your attempts is less than the number of times you're supposed to retry, attempt again, and otherwise raise the error. Very simple. And then you call attempt 0. It's just that easy. And we could wrap it around, calls to our data source, calls to back-end services, things like that. And so these become reusable tools, which is really a nice realization for us. Let's see. So the other, I mentioned lifting interpreters. So, I wanted to be able to write this, interpreter and then lift to Cleaver, right? So we created an object to hold these these lifts, and it's very simple. What we want to do is we want to just take any output and turn it into Cleaver. So to do that is very simple. Ignore the argument and return exactly what you have as your input. So are we done? It's always a good question. Our code has become a lot cleaner and easier to understand. It's easy and pleasant to add new endpoints. I've got happy developers that were gushing about the techniques to my manager, which is always a plus. But we're not done. I think I'm always striving for better, cleaner code organization, less boilerplate in the code, and we're still learning how to sort of build the power into our interpreters and figure out what else we can do. And additionally, we need to spread the knowledge. Spread the knowledge outside of our small team and into larger teams within Comcast. To that end, we did onboard a new developer who was fairly even new to Scala, and she picked up very quickly the techniques that we were using. And so I consider that a win for our education forward in using this technique. So I guess sort of to conclude, maybe a little early, write the code that you want to see and then make it work. This is the mantra that I've started using at work. And this was actually really important because I had a lot of developers that were writing code that worked, but it wasn't code that you wanted to see. The free monad is one tool to do that, which requires some initial ramp up. It's not easy, but it is ultimately rewarding. My advice is to find an approach that works for your team, and then share. So you can always tweet me at @dscleaver, and that's it.
Any questions? You have a few minutes.
Yeah.
So you guys seem to be sort of the high watermark in large organizations using these techniques to do stuff.
Mm-hmm.
Something I'm wondering about is when it comes to the code-free and free representation screens. In my mind, I'm just getting my head around that now, but in my mind, that seems like it's sort of could rise to being a similar pattern, all-encompassing pattern, like have you guys played with that at all yet? Or
So are we considering co-free essentially as an analog to free?
for streaming?
I watched John's talk, and I'm very excited to learn more. As I said, I bring techniques in, right? So I'm going to explore it probably first and figure out where we could apply it. I have looked at FS2, and I'm very excited to try that as well and get that maybe into our team. So I have the advantage that Michael works for Comcast, and so I've already told him that I'm going to co-opt him into some training, because I can convince my boss, hey, if we just buy Michael lunch, he might do some training for us. So So yeah, I think it's a technique I'm very interested in. So, any other questions? Yeah.
What do you think is the overhead of free monads?
I've done some. What is the overhead of free monads? I've done some sort of back of the head, not even writing it down on a napkin type calculations. I feel like there's not maybe as much overhead as people say that there will be. There's definitely going to be extra stuff in memory, but a lot of it's going to be eaten space, right? So it's going to be stuff the JVM's just going to throw away as soon as it gets an opportunity to. So we haven't seen a lot of performance impacts on it. So, I'll evaluate it. Performance is a funny thing, right? People talk about making things faster, but they don't really talk about where they need to make things faster. And so I think you have to evaluate in the case. I used to do tight loop optimization things, right? And at that time in the JVM, you couldn't even create objects without it being slow. And so we eliminated all object creation. But for something that's, a RESTful call that maybe a customer makes every 5 minutes, if it's an extra couple of milliseconds slower, I'm not really going to lose any sleep over it. So, anybody else?
Well, thank you very much.